In this video, we're going to talk about describing quantitative data with boxplots. So building on the information that we talked about in our last video, which had to do with quartiles and the interquartile range, that's something that we call a 5-number summary. So that includes a minimum and a maximum, the first quartile, Q1, the median, and the third quartile. So visually, to represent that, we create something called a box plot. So these two diagrams here, one of them is a dot plot that has to do with highway fuel economy from those Toyota 4Runners, and you have the same information here as you do here in this box plot, but it's very clearly representing that 5-number summary. So over here you'd see the minimum, and over here you'd see the maximum, and then this box here takes the majority of your data that are not outliers, right, which you can find with the IQR times 1.5, which we talked about in our last video as well. So this right here, the starting of your box is your Q1, the end of the box over here is Q3, and then this line down the middle is your median. And then these whiskers, so it's also called a box and whisker plot, if you've ever made one of those and you've made a box plot before. So those whiskers start at your first and end at your last data points that are not your outliers. So let's talk about how to make a box plot. First step is to find the 5-number summary. So that's your minimum, your maximum, your Q1, your Q3, and your median. You want to identify outliers, and that's that 1.5 times IQR rule. IQR Q3 minus Q1 times 1.5. You want to draw and label the axis. There's only one axis. It's horizontal. You put the name of the quantitative variable underneath and any units that it has, because that's important. You scale the axis. You look at your minimum, your maximum, you make it that big. You draw the box. So the box starts at Q1 and ends at Q3. And then a line that you'll draw somewhere between Q1 and Q3 is your median. That's going to break up your box there. And then you draw your whiskers. And those are lines that extend from the ends of the box to the smallest and the largest data values that are not outliers, like in that last example. And then you mark any outliers with a special symbol, such as an asterisk. So now let's put those steps to the test with an example. So this example is all about picking pumpkins. Is it almost pumpkin season? Is it pumpkin season? I don't know when you're watching this video. So the problem is explained as some students purchased pumpkins for a carving contest. Before the contest began, they weighed the pumpkins. The weights in pounds are shown here. So let's first make a box plot of the data, and then we'll get into examining and summarizing and interpreting that data. All right, so what we have to do first is find the 5-number summary. First thing I did is I wrote out all the numbers in numerical order. So the lowest number was 2.0 and the highest was 33.0. So tiny pumpkins up to some pretty hefty ones. So there were 23 weights in total. So that made it a little bit easier to find the median. I just counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 on each side. So all the yellows here are 11 and all the greens here are 11. So that means that the 12th one in from either the lowest end or the highest end, that's going to be the median. So what I'm going to do is I'm going to take the first half and the second half and determine our Q1 and our Q3. So the midway point between the first set of our data here is 4.0, so that means Q1 is 4.0, and the halfway point in our second half of the data is 12.7, so that makes Q3 12.7, and of course the other two values are minimum at 2.0 and our maximum at 33.0. So with that first step done, right, our 5-number summary, minimum, maximum, Q1, median, Q3, we need to identify outliers. So that has to do with that 1.5 times the IQR. So we got to find the IQR first. So that's the difference between Q3 and Q1. That's going to be 8.7. So the low outliers is going to be less than the Q1 minus 1.5 times that 8.7. And that ends up being negative 9.05. There's no pumpkin, at least in this realm, that weighs negative 9.05 pounds. So there's no low outliers. High outliers, we take that Q3 and we add it to that 1.5 times IQR, and that ends up being 25.75 pounds. And there's 2 outliers there. So we've got 2 high outliers, one at 31 pounds and one at 33 pounds. And those in our box plot are going to be represented by asterisks. All right, now onto the fun stuff. Let's actually make this box plot. So I've got all my information up here. I'm gonna first draw and label the axis and then scale the axis. So I know that my minimum is gonna go from 2 and my maximum's to 30. So those are the two things that are gonna help me out here. So I made a horizontal line. I made notches every 2, counted by 5, so that'll cover my range here. I've got 0 to 35, which will cover the 2 to 33, and then I labeled my axis as pumpkin weight in pounds. So the next thing that we're going to want to do is draw our box. So that is where our Q1, our median, and our Q3 come in handy. So I'm going to make a vertical line at about 4.0 for Q1. You don't have to color code it, but I'm just trying to make it as obvious as possible. And then Q3 is 12.7, so that's my blue line here. That's going to be my IQR actually, right? Because 12.7 minus 4 is 8.7, so that is the range or the distance of that box. And then our median goes at 6.6, so that's that red line, or pretend it's a red line, it's a little shaky. And then I just topped it off top and bottom. So there's our box. So we've drawn our box, we mark our median, and now we need to draw our whiskers. So I don't know why I say them like that. So that's going to go from the smallest to the largest data values that are not outliers. So going to have to go back into our data and find out what our next highest number is before 31. So looking back, that number is actually 15, quite a far cry from 31 and 33, which makes sense as they are both our outliers. So our minimum is 2.0 because that is not an outlier here. So that is the left end of our whisker. We join that with just a line right there to our Q1 value. And then that 15 gets marked out here, and then we draw a little line to our Q3 value. So the last thing that we got to do is mark our two outliers with asterisks. Here are two outlier friends out here in asterisk world, and here you go. Here's a box plot of our data. So much fun. The second part of this example asks us to explain why the median and the IQR would be a better choice for summarizing the center and variability of the distribution of pumpkin weights than the mean or the standard deviation would be. So as a reminder, our median here is in pink. That's that line right here. That is in the middle of our box. Also, I will say that you can always color in your box if you want to, if that floats your boat. And then the IQR, remember, is the distance from Q1 to Q3, and that's about 8.7. So why median and why IQR over mean and standard deviation? So as a reminder, mean and standard deviation are sensitive to outliers, which we have two way out here, and the median and the IQR are not. So in this example, this data is skewed to the right, because remember the tail with these two outliers would be over here. If we were thinking in terms of a dot plot or a stem plot, it would look something like that. So median, IQR, not sensitive to outliers. So those, in this situation, with these two giant outliers out here, would be the better choices for summarizing the center and the variability of our data. Also, if you're ever using statistics software, sometimes they display box plots vertically. So this is what our box plot of pumpkin weight would look like if it was vertical instead of horizontal. Just wanted to show you. So something about box plots that you may have noticed is that they don't show gaps, clusters, or peaks. They may not be the best visualization tool depending on what you are looking to visualize. So here are two examples. We've got a dot plot here and a box plot here, and they are representing 220 eruptions, the length of them, of the Old Faithful geyser in Yellowstone. Yellowstone? Yes. Highly recommend. It's beautiful. Beautiful. Anyway, what you can see here is you can see that we've got a bimodal piece of data here. We've got two peaks. We've got two roughly symmetric peaks. They're beautiful. This might give you more information, depending again on what you are analyzing your data for. Whereas this box plot is far less interesting, at least in my opinion, and doesn't really show you much about the shape of the distribution. So just keep that in mind when picking how you want to represent visually your data. So let's do one last example where we actually compare the distributions between two different box plots. So in this problem, we are going to answer the question, which company makes better tablets? Riveting. So the problem says, in a recent year, Consumer Reports rated many tablet computers for performance and quality. Based on several variables, the magazine gave each tablet an overall rating, where higher scores indicate better ratings. The overall ratings of the tablets produced by Apple and Samsung are given here, along with parallel box plots and numerical summaries of data. I'll show that to you on the next slide. So let's compare the distributions of overall rating for Apple and Samsung. So here's the raw data here for Apple and for Samsung. And so this is what our box plot looks like. We can see that, at least for me, starters, our IQR is smaller here than it is here for Samsung. We've got 2 outliers in Apple, and the minimum and maximum values are much, much wider. Our range is much bigger for Samsung than it is for Apple. So here's a handy dandy little chart that has all of the information depicted here, or most of the information, but it's a little bit easier to read. Maybe hopefully your eyes are better than mine, but I like a good chart with the actual numbers. So this chart tells us the mean for both Apple and Samsung, their standard deviations, their minimum and maximums, Q1, median, and Q3, and their IQR. And I'm gonna plug our little saying when we analyze distributions of data. Statistical opinions can vary, so that is shape, outliers, center, and variability. So starting with shape, we can tell that the bulk of our data, or our IQR, is going to be here on the right-hand side. So that means that our tails are over here to the left. So I would say that both are skewed to the left. And for outliers, we can see that there are 2 outliers for Apple's distribution. Looking at the list of data points, I could tell that they were at 73 and 76, and Samsung has no outliers. And looking at center, our median is where we're going to look, is very close. So Apple beats out Samsung by 1 point at 84 instead of 83. So they're very close. But something else I looked at was that I wanted to see how many of Apple's overall ratings in their raw data were either 83 or above. And 16 out of 20 of those, which is 80%, are higher or the same as Samsung's median score. And last but not least, something that this box plot shows well, in my opinion, is the IQR, which gets to variability. So there's way more variation in Samsung's scores than Apple's. And Samsung's IQR, so that interquartile range from Q1 to Q3, is nearly 4 times that of Apple's, where Samsung's is 11 and Apple's is 3. And that's going to do it for this video. I'm going to see myself out for that. Sorry. Again, not sorry.